Hi folks, I'm going to talk about the equation of statics, very important ones. So I'm going to, probably you have been through that one, I'm going to go a bit fast. If I have a body and I have a system of forces, so this is the body, is a potato, and I have a system, this is the axle Z, this is the axle Y, and this is the axle X. And if I have a system of forces, P1, P2, Pn, and if I have a system of moments, a couple of forces, M1, M2, MM, as we're going to see in the lecture that I put into the blackboard, all this system, after all, can be reduced in one force only, which is the resultant force, and one moment only, which is the resultant moment. So, how can we reduce? We bring the force in the center. All the time when I bring the force, I have to add the moment. The moment can be are free vectors, so I bring everything in center. And if I have all the vectors in one center, I can add them as we did in the assignment. So after all, I'm going to have one force and one moment. So now, if I have one force, the body is going to move. If I have one moment, the body is going to rotate. If I have both, it's going to move and rotate. But I want to be in equilibrium, so what is the condition of equilibrium? This force has to be zero. If this force is zero, it's not enough, because it's going to rotate. If the moment is zero, it's not enough, because it's going to move. But if both of them are zero, there's nowhere to go. So this is the condition of equilibrium. So the total force and the total moment should be zero. But we write these conditions analytically. What does it mean analytically? Means that the projection of force in the axle X equals zero, the projection of forces in the axle Y equals zero, the projection of forces in the axle Z equals zero. Because that's what we dealt. We dealt with projection because when we have projections, we can use the vectors as scalars. We can add them. And the same, the sum of the moments about the axle OX equals zero, the sum of the moments about the axle OY equals zero, and the sum of the moments about the axle OZ equals zero. These are 6 equations of statics. So this guarantee the body in space, the equilibrium of the body in space, under, it doesn't matter what system of forces. As I said before, we're going to deal with plane problems. So this body is going to be in the plane XY. So this is going to be our plane, the plane YX. So in this case, I need this equation, sum of the force in axle X equals zero, and sum of the forces in the axle Y equals zero. And I don't have any force in the axle Z because all the forces are in the plane, and axle Z, as you said before, is a nail here, is this axle. And sum of the moments, so if I have those forces in the axle X and Y, those forces cannot give moment about the axle X and Y because there is no distance. Remember, we mentioned many times, but now it's in the video so you can remember, if the force and the axle are in the same plane, there is no rotation, there is no moment. And many times I said, if I am a cat or a monkey or a Spider-Man and I'm standing on the door, I cannot open the door. I have to be outside because there is no distance. And because there is no distance, I have no rotation because 2 lines in the plane either cut each other or they are parallel. So the only equations that is this one, the sum of the moment about the axle OZ, and the axle OZ is a point here. So these are 3 equations of statics. 6 degrees of freedom in space, 6 equations. 3 degrees of freedom in plane, 3 equations. So it means that if in a problem I have 3 unknowns, I can solve those equations. What do? I have to find the projections, which we learn how to find, first assignment, and I have to find the moment of those forces, which we learn how to find was the second assignment. That's what we did, those assignments, to come to this point, to solve every problem of statics. And one of the particular cases is when all those forces are intersecting in one point, and we call this one concurrent system of forces. So if these are the forces F1, F2, Fn, these forces intersect in one point. So it means that the moment of those forces about this point is zero. So the third equation is going to give me nothing, 0 equals 0, which I know. So in this case, in concurrent system of forces, I have two equations only. So I have to have two unknowns to solve it. If I have three, I cannot solve it, of course. And the particular case is when all the forces are in one line. If all the forces are in the axle x, sum of the forces in the axle x equals 0 is enough. What does it mean? For example, if I have here the force 5 Newton and the force 8 Newton, of course, to be equilibrium, is this force has to be 13 Newtons. So the sum is 0. Of course, this is very easy. We're not going to deal with this one. We're going to deal with more complex problem. All you have to remember when you have to solve an equation, a problem in statics, what should you do? What is the general way of solving? First, look the degrees of freedom, if it's statics. Second, remove the support, put the reaction. So, first step is look the degrees of freedom. Second, remove the support, and put the reactions, So in this case, we build the so-called free body diagram. What is free body diagram? The structure, we keep some important things. First, we have to respect the number of degrees of freedom. Second, we have to respect the geometry of the structure. And after, third step, I'm going to change, write the equation of statics. And this is the normal way we solve the problem in statics. We have seen examples, we keep seeing examples, we are going to continue with examples. That's enough for today so far. Thank you very much, guys.